We are building the Fractals and Recursion program from the YByte Python curriculum available at www.ybyte.in. In the previous video, we did our first recursion, which was basically a square drawing itself. And the structure of the code was we drew a square, and then if, let's say, L, which was the length of the square, we are passing that as an argument. If that happened to be more than 10, then we called this function once again. And we saw that it kind of created a nice pattern. But let's take a deeper look into what is going on so that we really get a picture for what's happening here. Remember, the code basically is draw and then call a function. So when I, let's say, go to the command line and call, say, square 0, 0, 100, what I'm saying is that, look, x is 0, y is 0, and L is 100. And hence, I draw the first square. Now, remember, as part of the function definition, there is a call to the original function, the recursive call. So the function itself, as it runs, since my L is still more than 10, it goes and calls 100, 150. Now, important to understand that this call I am not making from the command line. This call is being made by the function itself, and hence I call this as a recursive function call. Once again, this function runs. Now, again, I draw my square, and since L is still more than 10, I just say, okay, look, x plus L, y plus L. So that has to be 150, 150, and 25. I keep going down until I come to a point where, let's say, my x is, say, 12.5. So that is my square number 4. Now, once this happens, remember, I'm going to call this same function with x plus L, y plus L, but L by 2. So now I have 6.25 as my, let's say, L value. This time round, the square does get drawn. So that is my square number 5. It does get drawn with side of 6.25, but the function does not call itself. And that's why the recursion stops. But you notice I get square number 1, square number 2, square number 3, 4, and 5. Now let's see this in yet another way, because this is really, really important. When I call, for example, from this command line, square 0, 0, 100, remember, this is just a regular function, which means that my execution shifts to this function. I end up drawing the first square, and then I implement this if statement. If L is more than 10, I go and call this function again. Now, once this function is called, even though I did not call it from the command line, it's going to behave exactly like a regular function, which means that I'll again draw this square. And then I ask myself, if L is more than 10, I will call this once again with different parameters. So that's 150, 150, 25. Again, this function runs from top to bottom. Square gets drawn, and I call 175, 175, 12.5. Square gets drawn. I ask myself, okay, is L more than 10? It's in this case, yes. I go and draw the square. Now L is no longer more than 10, and hence the recursion stops. But you notice that all the 5 squares have been drawn, and each function basically exits out. Eventually, I'm here and I come out of this, right? So very, very important to visualize it this way and understand and recognize that recursive calls are basically just like calling the function. The only difference being that this time round, we are not calling it actively. It's the function that is calling itself. So that's why it's called recursion. But other than that, the code still runs from top to bottom, and every part of the code gets done as though it's a fresh call. Very important to realize this. I hope this has given you a better picture of how the recursion is working. Of course, we are going to get deeper into all of this as we go forward, but I hope this has been interesting. Again, this way of learning emphasizes practical application of concepts. Look at our website www.ybyte.in to learn Python programming through such fun activities. Take care. Thank you so much. Bye-bye.